Hello, Intro to Stats class. Today we're going to learn about sample spaces and probability. First we start with probability. Basically probability is just a mathematical term for word chance, where we're looking for what are the chances for some particular event to happen. So like for an example, in day-to-day life, what are the chances it will rain today, or you're getting heads or tails in when you flip a coin, or when you roll a die, what's the chances you get 1, 2, up to 6, whatever number, or for different things. So basically probability is a numerical value. It's a numerical value called and that is basically uh, predicting the chances for particular event to happen. And when we talk about probability, the answer for probability could be in three forms. It could be in fractions, decimals, and percent. And how to find the probability? There is a very simple formula for probability. That's this one. That is, probability of an event occurring is number of ways an event can occur over total number of outcomes. So it's basically we talk about, if suppose there are 10 times something is happening and we say 5 times a particular event will happen out of 10, so that's the probability for that particular event. All right, so let's see an example on next page here. If you're talking about sample space, and sample space is basically probability experiment, we already talked about, is just an action trial that has varying results, and outcome is what? Outcome is basically the result of that experiment. And if you're rolling a die, 6-sided die, so the possible outcomes are going to be 1, 2, 3, 4, 5, 6. Same way, if a collection of one or more outcome is an event, you just collect the outcomes. And suppose and whenever you collect all the possible outcomes, set of all possible outcomes, that becomes a sample space. All right, so let's see an example where we're supposed to find the sample space for an experiment. All right, and the experiment, if you flip a coin, this is a coin, and for coin you could have two outcomes. For this coin, it could be heads or tail. It could be same heads or tail, and here also it could be either head or tail. So when we try to find our sample space, there could be a few situations. First situation, either you get all heads when you write down your sample space, or you get all tails. That's one scenario. All right, and how to write the sample space? Next is, either there is one tail when you flip it, so it is head, and this is tail. Let me make it green here. Or your other scenario could be, either you get head and tail is coming from the second coin, head, or could be a case when your tail is coming from the first coin, tail, and then head. Or, so this is one when the top one purely just one kind, here just one tail. And let's see the third case when you have two tails. So how we can have that? So that can be like this. If we have one head, then we can have two tails like this. Or what is the other way I can have the tail? Either I can have tail here and tail from the third one and head from the middle one, or I can have tail from the first two and the head from the last one. So this way you can always create a sample space. So this whole list is the sample space for the given experiment when you flip a coin. All right, flip 3 coins one time. So that's your sample space, let's move to the next part. We're going to talk about the probabilities. There are two kind of probability. One is theoretical probability and other one is experimental one. So theoretical is basically it specify that what are the chances or for a favorable outcome, what are the chances some particular event will happen or most likely to happen, or and the outcomes are equally likely. Keep in mind, when the outcomes are equally likely, in that case how can we find the theoretical probability? For theoretical probability, here we have this is the formula for that. Theoretical probability, that's number of favorable outcomes over total number of outcomes. As I told you, for any kind of probability, this is the basic one. Like you get your grades, if you're getting 9 out of 10, so 9 out of 10, that's something like that. So the probability of even A is written, that's the way how you denote it, probability of A. And there are few criterias here. So there could be few categories. Either some event is going to be impossible. Suppose it's I'm living in California, and I'm saying that during summer there is a snowfall, so it's impossible. But during winters, if I'm living in East Coast, so snowfall is certain. So the probability in that case it's 0 here. For impossible event, for certain event, it's 1. What is the probability when it's likely? It's just likely to happen or not happen. It's in middle, so that's 1/2. That's, and then when something is unlikely, means it's between 0 and half, means more towards impossible, but it's not completely impossible. That's 1/4 here. And something is likely means more towards the possibility, less likely not to happen, so that's 3/4. So as I told you before, that it's going to be written in fraction. So the probability it's in fraction, or it is in decimal. You convert the same values in decimal. So these are decimals here. 1/4 is 0.25, half is 0.5, and 3/4 is 0.75. Or it could be in percent. So you can convert that into percent. And how to get decimal to percent? You just multiply by 100. So 0.25 is 25%. This is 50, 75, and 100% sure something is going to happen. So that's your theoretical probability. We learned about theoretical probability, but let's see an example for that, what it is. So we have an example here. So for that example, what's being told when we asked about the probability of a coin landing on heads, you would probably answer that its chances half. All right, it's 50% chances that it would land on its head. So imagine the toss, you toss the same coin 20 times, and how many times would you expect? Here this is very keyword, expect it to land on heads. So you will say, I expect it to be 50%, or half of the 20 times, or I can basically say I would expect 10 times I'll get heads. So that is my theoretical probability. All right, so that is my expectation. So theoretical probability is what you expect to happen, but it's not always actually what actually happens. So next part, I'm going to show you in next example. Before next example, we're going to discuss about the experimental probability, and then we refer back to the same example. Experimental probability, it is what? It is based on repeated trials. So it means if you talk about experimental probability, you will see some experiment. You do the trials and then you find the probability of an experiment. So it's repeated number of times, and then you find how many times favorable outcome occurs, and that's called success. Success means how many times you're seeing that thing is happening. Like so the formula for this is experimental probability is number of successes of over number of trials. It's the same thing. If you are getting 5 over 5 times over 12 times means 12 times you are flipping a coin, you're getting 5 heads. So that's the experimental probability of that. So if we are going to connect that to our previous example, theoretical probability is what you expect to happen but is not actually what happens. But if I'm connecting it to my experimental probability, same thing, flipping a coin, if you toss it 20 times, so what you can see, if you're tossing it 20 times, so in an experiment a person got 13 times head and 7 times tail. So in that case, experimental probability is going to be 13 over 20, and that's basically, this is in fraction form, this is in decimal form, and this value is in percent form. So theoretical probability was 50. So theoretical was for the same thing. Theoretical, we were expecting there were 50 heads, but when we did the experiment, experimental probability is 65%. That can change from experiment to experiment. So any question about the probabilities basic definition, let me know, and next videos I'm going to do few questions based on that. Till then, stay